Welcome to Mickey Study Circle channel. In this video, we shall see how to do the orthographic projection of planes using the Solid Edge software. Coming to the problem statement. A regular hexagonal lamina of sides 25 mm is lying in such a way that one of its corners on HP, while the corner opposite to that corner on which it rests is on VP. If the lamina makes 60 degrees to the horizontal plane, that is HP, draw the projections of the lamina. So looking at this problem statement, we can arrive at a set of conclusions. The first one is the type of polygon given to us is a hexagonal plane. So that is a polygon with 6 sides and each of the sides measuring 25 mm. And also the resting condition is it is resting on one of its corners on the HP. And coming to the inclination with respect to the HP, it is inclined at an angle of 60 degrees. Coming to the inclination with VP, the data is not given to us, but however, the condition says that the corner opposite to the corner on which it is resting is touching VP. So if it is resting on the corner A, then the opposite corner to that resting corner on the HP shall touch the VP. So this is what is the condition. So with this condition, let us see how to draft the solution for this problem statement. So let us begin by constructing the XY line of thickness 0.18 mm. So let us draw a line of any arbitrary length and annotate the line as X and Y. Also, the reference planes shall be annotated as VP and HP. This is the first step. The next step, we shall select the line option and draw the top view of the hexagonal lamina in such a way that it is resting on one of its corners. So the edge length is 25, the initial angle is 0, followed by the edge length of 25 and the angle being 60 degrees. Next edge length 25, the next angle is 60 into 2. Next we shall draw the edge of 25 mm length, 60 into 3, 25, 60 into 4, then 25 followed by 60 into 5. So this completes the construction of the top view of the hexagonal lamina resting on one of its corners. Now select the text option from the annotation menu and annotate all the corners of the hexagonal lamina. So this is corner A. So as per our condition, it is resting on the corner A on HP. This is corner B followed by corner C, corner D, corner E, and corner F. So now we shall draw the front view of this lamina by selecting the line of thickness 0.13. So from each of the corners, let us try to draw the projectors intersecting the XY line. From corner B through the corner F, intersect the XY line. From corner C through the corner E, intersect the XY line. And from D, intersect the XY line. So trim the point of intersections of the XY line from the vertical projectors and draw the front view of the lamina by selecting the line of thickness 0.50. So from corner D to corner CE endpoint, from this endpoint to this endpoint. So ensure that the line is a broken one and it is not a single continuous line, so that we'll be able to get these corners to draw the vertical projectors and the horizontal projectors in the consecutive views. So now we will draw the next inclination. So before that, we shall annotate the front view of the lamina. So the corner A dash is visible. So it is A dash. And here for the observer, corner B dash is visible first, followed by the corner F dash. And next, corner C dash is visible and corner E dash is visible. Is not visible, so it is inside the bracket. And here this is corner D dash. So this completes the front view of the lamina. Ensure all the annotations are on the same line so that it looks neat. So this completes the top view of the hexagonal lamina and the front view of the hexagonal lamina. So now we'll go for the second condition, that is with respect to the HP, it is inclined at an angle of 60 degrees. So for that, let us select the front view of the hexagonal lamina, all the three parts of the hexagonal lamina along with the annotations. Select the move option, ensure the copy is on, and keeping the point or the corner A dash as the point of reference, move it towards the right hand side of the XY line. Okay, so now this completes the first part. So with respect to the VP, he tells that if it is resting on the corner A initially, the corner opposite to that corner is corner D. So corner D must be touching the VP. So with this condition, we have to ensure that the corner D is here on the VP, and then the corner A, it is resting on the corner A. So finally, we have to arrive at the corner A in the final position. So ensure that we are going to rotate this in such a way that the corner A is on the XY line. So select this parameter again, that is the annotations and also the views, the front view. Select the rotate option, ensure the copy is off. And now this is the first point of rotation, that is corner A, and second point of rotation is corner D, and rotate the lamina with an angle of 60 degrees with respect to the HP. So this completes the second step. So now let us draw the vertical projectors downwards to get the top view of the lamina in this condition. So from corner D dash, from corners C and E, similarly from corner B and F, and from corner A. Then from corner B, it is intersecting the projection line here, that is C and B. And similarly, D is going to intersect here. Corner E and F is going to intersect the projection lines here. So we shall complete the front view, sorry, the top view of the lamina. So this is the end point, point of intersection, point of intersection, point of intersection, end point to the end point. Okay, so now we will annotate. So this is corner A, corner B, corner C, corner D, corner E, and corner F. We shall trim the projection lines which is not required to us. So with this, we complete the second portion of the problem statement, that is, the hexagonal lamina is inclined at an angle of 60 degrees with respect to the horizontal plane. So now we shall draw the next position, that is, the corner opposite the corner on which it is resting is touching the vertical plane. So with this condition, now let us select this hexagon. So before we select the hexagon for the third position, we shall make this a rigid object. So select the entire polygon and make it rigid in the relate menu and click on accept. So now the entire polygon is rigid. So what happens is, whenever we are trying to move the polygon, there are chances that the lines might get separated. Hence, we will select the entire polygon and make the whole set of the polygon as a rigid set. So now we will select this polygon along with the annotations. So first select the polygons and then select the annotations. Select all the 6 corners and select the move option. Ensure the copy is on. So keeping D as the point of reference, place the corner D on the XY line. And now select the rotate option. Ensure the copy is off. First point of rotation, second point of rotation is the corner A, and rotate the polygon in such a way that the angle of rotation is 90 degrees. So the corner D, which is opposite to the corner A, is touching VP. So ensure all the annotations pertaining to the top view is below the XY line. So this is corner D, which is touching the XY line here, as you can see. So now let us complete the inclination by drawing the front view of the polygon. So select the projection line of thickness 0.13. So draw the projectors from all the corners, that is D, C, E, B, F, and A. So this is the corner BF. So from FE, we shall draw the projections. From AD, draw the projections. And similarly from BC, draw the projections. So now we will complete the front view of the hexagonal lamina by selecting the line of thickness 0.50. So let us take the point A as the reference. So from A to corner B, the point of intersection. From B to corner C, endpoint D, endpoint E, endpoint, the point of intersection here, corner F, and from corner F to corner D. So now we will annotate. So this is corner A dash, followed by the corner B dash, and this is the corner C dash, corner D dash, and corner E dash, and this is the corner F dash. So select the trim option and trim the projection lines of unnecessary length. So you can just see that if you use the zoom option, the projection lines is exactly not passing through the corner D. So such mistakes can be easily identified with the help of the zoom out options. So we will just trim this and rectify the error. So select the line of thickness 0.13 mm, and then from the corner D through the corner A, from corner A through the corner D, draw this line first and then use the extend to next option. So this line is extended to meet the horizontal projector lines. So now you can see that it is exactly passing through the corners, which was not the case earlier. So now we will complete the front view from B to the end point D. So with this, we complete the problem statement. So to sum up, we have got a hexagonal lamina resting on one of its corner A, and it is inclined to the horizontal plane at an angle of 60 degrees. And this is the front view and this is the top view of the hexagonal lamina. Next, the condition is the corner opposite to the corner on which it is resting is touching VP. So as you can see that in the next condition, the corner D, which is opposite to the corner of resting, that is A, is touching VP, and this is the front view of the hexagonal lamina. So how do we validate? It is resting on one of its corner A initially, and even in the final position, it is resting on one of its corner A dash. So this completes the problem. You can indicate the directions of the projection line by using the leader option from the annotation menu. So place the arrowheads on the projection lines indicating the directions in which the projection lines are drawn. So with this, we complete the problem statement. Thank you all for watching.